Assalamualaikum warahmatullahi wabarakatuh. In this video, we will talk about drive belts. So, in this topic, we will cover 3 subtopics. The first one is introduction, terminology, classification and designation. Second, we will go into introduction of belts drive for flat, V and tooth belts. And then last, we will go for design of flat belt and V belt pulley. Before this, we have already seen several types of machine element like the power screw and shaft. So before this, all of the machine element is a rigid machine element types. There is another types of machine element we call it a flexible machine element. So when we talk about flexible, there is some advantage to it. First, in terms of flexibility, it can absorb a good amount of shock and vibration. And then second, because of flexibility also, it can take some degree of misalignment between driven and driven machine. And then third, because of flexibility also, long distance power transmission is possible when we compare to maybe power screw or gear, because power screw and gear usually are used in short distance power transmission. So there are several types of flexible drives out there. First is belt drive, and then we have chain, rope and roller chain. As you can see here, so there is 3 figure here. So all of them is a flexible types of machine element. In this figure, the first figure, this is the belt drive. Belt drive, the V belt. And then we have rope with pulley. So this is our rope, and then this is the pulley. And then the third figure is roller chain. This is our roller chain used in motorcycle. So all of this flexible machine element is used as a power transmission. Flexible machine element in industrial application, there is some application we can see here. First, usually we can see flexible machine element is being used as a conveying system, which is to transport material, such as by using conveyor belt. And then second, of course, used for transmission of power, which in terms of using prime movers like electric motor, engine. And then third, we can also use the flexible machine element to replace or to improve or to repair or to modify a rigid types of power transmission, and then use the flexible types of machine element, such as gear drive can be replaced by a belt transmission system, which is more cheaper in terms of maintenance and can be used simple, not complicated as the gear drive. So as you can see here, this is example of industrial application related to flexible machine element. So the first figure is conveyor belt. We can see here, this is the conveyor belt used to transport a material. Maybe this is the raw material before being processed. And then second, of course, used as a power transmission. So in this figure, this is example of flat belt used in power transmission system. There are several types of flexible machine element out there, but in this topic, our focus is the belt drives. So what is a belt? Belt usually is a loop strip. So when we talk about loop, the belt usually is not disconnected. Usually always in complete circle of belt, non disconnected. And of course, belts normally are made from flexible material, and then used to link 2 or more rotating shaft by using pulley. Okay, so usually belt are loop over pulleys, and then this pulley usually attached to the shaft. In two pulley system, the belt either can be in the same direction or can be operated in opposite direction. So how does the belt operates? So the belt operates because of the friction. Why? Because friction between the belt and the pulley is the one who responsible for transmitting power from one pulley to another pulley. So if there is no friction between belt and pulley, so there is no power can be transmitted. So in terms of pulley, there is two types of pulley. The first one is driving pulley, and then the second one is driven pulley. So driving pulley is the pulley which give motion or power to the belt, and then the driven pulley is the pulley which the belt transmit the power or motion to the driven pulley. Belts usually will not break because of overload, because if overload happen, the belt usually will only slip. When compared to the shaft connection, belts are more versatile because of that flexibility advantage, and then can be large center distance between shaft to another shaft when we compare to shaft connection. But belt will increase the bearing load because of the initial tension required for that belt. And then last, belt will not provide the same speed ratio because of the slippage. There are some advantages related to belt drive. So first, they are simple and of course economical compared to others. And then parallel shaft are not required. And then overload and jam protection can be provided. Noise and vibration is damped out. And then by using belt, there is no lubrication needed, so less maintenance. And then belts are highly efficient, which is 90 to 98% of energy transfer, usually 95%. And then some misalignment is tolerable. And the last, they are very economical when shafts are separated by large distance. So when we compare to shaft and belt in terms of large distance, so belt is more economical. There is some disadvantage of using belt drive. The first one is the angular velocity ratio cannot be necessarily constant due to belt slip and stretch. Second, due to the belt using or operated in terms of friction, so heat build-up is easily occurs. So in order to limit or to reduce the heat build-up, we need to limit the speed and the power transmit on that belt. And then because it is made from flexible material, we need to reduce or we need to limit the operating temperature, usually 35 to 85 degrees Celsius, because if that material in higher temperature, maybe it can expand the material. So when the belts is expand, so there will not enough friction happen between belt and pulley. So if there is no enough friction between belt and pulley, there will be a slip happen between the belt and pulley. And then if wear or stretch happen to the pulley, we need to adjust the center distance, or we need to use the idler pulley to make the belt and pulley contact. And then last, we need a mean of disassembly provide to install the endless belt. Compared to the roller chain, we can disconnect the roller chain and then join it back. But because of belt are usually made in loop strip, so there is a need for disassembly strategy to assemble the belt. So this is the difference between belt drive and chain drive, where I take this table from website www.difference.minbrand.com. There is several difference between belt drive and chain drive. So I just want to highlight the main difference between the belt drive and the chain drives. So the belt drive run by using the friction force between belt and pulley. So friction force is the reason why the power can be transmitted. Okay, the power and the power motion can be transmitted. But in the chain drive, power and motion is transmitted by engagement and disengagement of chain with sprocket. So this is the difference between belts and chain drives in terms of the operation. So usually belt are used in high speed with lower torque application, and then chain usually used in high torque but lower speed application. And then there is some disadvantage related to belt, which is must design with standard length, because usually belts are made in the loop strip, closed loop strip, and then it can easily wear, creep, and then corrosive environment can slip, temperature cannot be higher, we need to control the temperature. And then when the belt stretch, we need to use idler as a tensioner. So disadvantage related to chain, we need to maintain it by lubricated. We need to lubricate, and then easily to wear, noise and weight and vibration. Advantage of belt: quiet, flexible, and cost. And then for chain, do is strength and length flexibility. Length flexibility means that the chain can be reduced or can be add more in terms of length. So this is the belt construction here. Usually belts are made from leather, rubber, or canvas. And then usually belt can be either single ply, double ply, or triple ply. So here you can see single ply layer belt, and then so this is the direction, and then this is the hair side where the friction which is in contact with the pulley. And then we have the double layer, below is the hair side, contact with the pulley, and then this is the direction. So greater angle of contact is better. Why? So greater angle of contact means friction is more higher compared to lower angle of contact. So more friction, more power can be transmitted. So usually we can use the idler pulley to increase the angle of contact for that bulb. So idler is used to increase the angle of contact, which should not less than 160 degree. Here you can see the application of idler pulley. So this is the idler pulley, where by using idler pulley we can increase the angle of contact between bulb and the alternator, and also increase the angle of contact between bulb and pulley on the power steering pump. There are several types of belt drive system. The first one is open belt drive system, where the direction of driving pulley and the driven pulley is the same. And then second, we have the cross belt drive system, which the direction of driven pulley, let's say this is the driving pulley, rotate on clockwise. So this is the direction of driven pulley, which is rotate on counterclockwise. So direction of driving pulley and driven pulley are opposite. So we call this system is a cross belt drive system. So this is the another figure related to open belt drive. So we have the driver rotate on clockwise, and then we also have the driven pulley rotate on the clockwise. So as you can see here, there is two section of belt, the bottom and the upper. So on the lower side we call it a tight side, and then the top side we call it a slack side, because driver pulley drives or give motion to the belt by starting at this Q section. So what happens at this Q point, where the driver pulley will drives or pull the belt, loop the driver pulley. So in this point, the driver pulley pull the belt, loop the driver pulley. So in this section, what happened, there is a force or power here. So as we can see here, this section is a tight side, because of that pulling action taken by the given by the driver pulley. And then on this slack side, what happened, so when the driver pulley rotates and then comes to the L point, so what happened to the belt at this point, the belt just move itself without no power or motion, without power, no motion still have, okay. And then what happened here, so when the belt reach R, okay, so driver will pull the belt, so the lower section will always be in the tight side because there is a power here and also motion. But on the slack side, okay, power is less compared to the tight side. So this is the example of open system belt drive. And then this is the cross or twist belt drive system. So this is the driver which rotates on clockwise, and then this is the driven pulley which rotate counterclockwise, so cross. So this is the reason why we call it a cross or twist belt drive system. So for this types of configuration, we still need to identify which side is tight side and then which side is slack side. So of course, in order to identify where it is the tight side, we need first to identify which one is the driver pulley. So in this figure, the driver pulley located on the left side, rotates on clockwise. So when the driver pulley rotates on clockwise, so we know that the first contact between the driver pulley and belt happen at point Q here. So what happened, when the driver pulley rotates, so the first point, which is the contact point between the driver and the belt, happen at Q. So this section where the driver will pull the belt rotates. So this is the starting point. So we can see here, this will be the tight side, because pulling of belt by driver happen at this section Q point. So this will become the tight side. And then when the belt pass through the L section, L point, so the belt will just move with less power. So this one we call as the slack side. So this is one of the example of cross or twist belt drive system. The third belt drive system is the serpentine belt drive system, where the use of idler pulley in belt system, where we know that by using idler pulley we can increase the angle of contact between this pulley, and then we also can increase the angle of contact of this pulley. So we can use one idler pulley in a system, in belt system, or we can use several idler pulley in one belt system. Let's say for this example, we have 1, 2, 3, 4 idler pulley used in one belt system. So this is the example of serpentine belt drive system in the engine. You can see here. And then we have quarter turn belt. So this is the quarter turn belt. Driver pulley drives the belt, and then this is the driven pulley. Quarter turn belt, and then quarter turn belt drive with guided pulley. Let's say we put guide pulley here. So this is the example of quarter turn belt drive pulley. We have a horizontal shaft here, horizontal shaft. So this is our pulley and belt drive, and then connected to a vertical shaft here. So first this is horizontal, and then at the end join to the vertical. So we call it a quarter turn belt drive system. And then we have compound belt. There is by using 2 or more belt in a power transmission system. You can see here the first belt and then the second belt join or transmit on the second shaft here. And then we have step belt. Step belt, where the pulley stacking in terms of increase or reduction of diameter of pulley. So here you can see the pulley is increased in terms of diameter, and then we can see here the pulley are decreased in terms of diameter pulley. So this is the example of step belt drive system. You can see here this is the belt, and then the pulley are stacking in terms of increase of diameter pulley. There are several types of belt drive used in machine. First we have flat, which run on tapered pulley, and then we have V-belt, which commonly used in machine design, and then we also have round belt drives, and then we have timing belt drive. So this is the cross section of belt for flat, V-belt, and circular or round belt. So for flat belt, the cross sectional area is flat, and then for V belt, The cross-sectional area is looked as a V shape here, and then of course circular around belt, the cross-sectional area looks like a circular or round. So flat belt are rectangular in cross-section, which is mounted on pulley, usually crowned at the pulley to prevent from belt from running off the pulley. Crowning is used. And then these flat belt are mostly used in factories and workshop where moderate amount of power is to be transmitted. And then we have V belt, which is designed to ride inside the groove. So there is a groove on that pulley. V belt is a very higher friction and then less back force and short shaft size. And then mostly used in factory and workshop where great amount of power need to be transferred. And then we have round or circular belt, which is used in factories where a great amount of power is to be transmitted, which can be the distance between that pulley can be more than 8 meters apart. Timing belt is the cock belt which drive the camshaft in the internal combustion engine. So we can see here, this is the example of timing belt used in engine. There is some terminology used in belt drive system. Before this, we have driven pulley and driving pulley. So driving pulley is the pulley which give power and motion to the belt, and then driven pulley is the pulley which given power or motion from belt to pulley. And we have pitch surface here, pitch surface, and then we have effective radius of pulley here, and then we have pitch line, we have belt thickness, the belt thickness here, and then we have the angle of contact. So angle of contact for small and large pulley are different, because for small pulley you can see here angle of contact is less than 180, but for large pulley usually angle of contact is more than 180. And then we have pulley diameter and distance between center pulley to another center pulley, we call it as a shaft spacing, symbol as a C. The friction force on belt normally is not uniform, but for calculation purpose, we will assume that friction force between the belt and pulley are uniform. And then we will make assumption which the tight tension is greater than the slack side tension in terms of force. We can find the value of transmitted power from driver pulley to driven pulley by using equation P is equal to TW omega. So T is for the torque and omega is for rotational velocity. Or we also can use to find power, transmitted power, by using P is equal to F1 minus F2 times with the V, speed. So F1 is the tight side, F2 is the slack side. So for speed, V is equal to pi dr over 60. So D is the diameter of pulley N is the rotational speed. And also we can find the value of torque by using F1 minus F2 times with R. So F1 is the tight side, F2 is the slack side, R is the radius of that pulley. Let's say we have two pulley, and this is the small pulley, and then this is the large pulley where connected by a belt. Because of these two pulleys are joined by a belt, we can assume that the speed on small pulley and the speed on large pulley is same, because let's say we call this the small pulley as pulley number 1, and then the larger pulley is pulley number 2. So speed for pulley 1 is equal to V1, and the speed for pulley 2 is V2. So we know that V is pi dn over 60. So 1 pi d for d2 for large pulley and n2 for large pulley over 60. So we cancel out 60 pi. So what left is d1 times with n1 is equal to d2 times with n2, where d we can reduce to radius n1 r1 n1 is equal to r2 n2, or we can make them as a ratio. So n1 divided by n2 and r2 divided by r1. So this equation where you can derive it. Now let us consider, let's say, a small pulley here connected to a belt. So usually small pulley, the angle of contact is only between this and this area. So this is the angle of contact. So the angle of where the pulley and the belt are not connected, so we can assume this is a alpha. So this angle alpha we can find from this formula, which is alpha is equal to inverse sine r2 minus r1 over c. So we can get the value alpha, and then to find the value of angle of contact or angle of wrap here, so what we need to do, if the pulley is small pulley, we can assume that angle of contact for small pulley is pi minus 2 alpha in terms of radian, or 180 minus 1 alpha here and then minus 1 alpha here. So what we got angle of contact for small pulley. If for large pulley, let's say we have large pulley, usually normal angle of contact for large pulley is more large, like here. So join here, and then this angle will be our alpha. So for large pulley, angle of contact for large pulley is 180, which is this section 180 plus with this angle 2, so plus 2 alpha. So there is some value we can find related to belt length and center distance. So first we can find the belt length by using this formula, which is belt length, which is L, is equal to 2c plus pi r2, which is the large pulley, minus r1, the smallest pulley, plus 1 over c r2, the large pulley, minus r1, small pulley, power of 2, where c is the center distance between two pulley, between the driver and driven pulley. So c we can find from 1 over 4 b plus b square minus 8 r large pulley minus r1 small pulley, power of 2 square root. And then B we can find from this formula, which is B is equal to L minus pi R for large pulley minus R1 for small pulley. There is some initial tension of belt is lost as the belt will stretch over a period of time. So there is a method in order to maintain the initial tension of belt. So first we can use the fiber-thread overhang motor drive, or we can change the belt and pulley material to increase the coefficient of friction, or also we can increase the center distance during the operation. Because of belt looping over pulley, there will be a centrifugal force acting on that pulley, Fc. So we can find this Fc value by using this formula, which is W is the belt weight per unit length, Newton per meter. So we need to make sure the value when we put in this formula, the value must be in the form of Newton per meter. And then G is for the gravity, external gravity. And then V square is the belt velocity. And then after we have find the value of centrifugal force, then we can find the value of tight side or slack side by using this equation. So F1 is the tight side, F2 is the slack side, Fc is the centrifugal force, and then E is for the exponent, F is the coefficient of friction of belt, and then theta is the angle of contact. So this is for the flat or round belt. But for B belts, the difference is they have the sine beta, which is beta is the half included angle. So what is the half included angle? So half included angle, which is beta, let's say we have a B belt here, and then we extend. So when we determine the angle between this, from this side to this side, so the angle is include angle beta. So for half include angle, we determine from center to any side. So let's say from this to this, so this is the half include angle. Also for B belt drive system, we can determine the tight side tension also from using this equation, which is F1 is the tight side tension, Fc is the centrifugal force, then gamma is the short form of exponent F for coefficient of friction of belt, and then this theta is for angle of contact, and then sine beta. So beta is the half include angle, and then T1 is this for top, and then R1 is the radius for small pulley. The smaller contact angle of the driver pulley usually leads to the large belt tension, and then this is very critical. So usually design of belt drive is on the basis of small pulley geometry. So for a maximum tension F1, B belt can transmit more torque and power when compared to flat belt or round belt.